So our next application with parametric equations is to use them to find area. Okay, so here's an example where we've been asked to find the area enclosed by this curve, which is given with these two parametric equations, that's t minus t squared and y, and the x-axis. So this curve, I drew the whole thing, but really they just want this little bit here. Okay, and we know that all you have to do is integrate, right? Y dx to find the area under the curve, but we don't have y in terms of x. So y dx like that doesn't really make any sense because both x and y are in terms of t. So what we need to do is mind you, this should be x equals a to x equals b, right? Because you're integrating with respect to x. So what we need to do is change the variable of integration so that it's t, which actually you can do, not hard, just by using the chain rule. What this is going to be, okay, we'll call it x as a function of t, f of t, and y as a function of t, d of t. And we want to change everything to t's, so we need to change the limits, and we also need to change this. Y is g of t, but we have dx, so we would have f prime of t dt here. Okay? So now the variable of integration is t, the limits are in t, but what are the limits, right? They have to be the same points, so you need to know what point this and that stand for in terms of t. Like if I look at it, looks like that's 2 and it looks like that's almost 4, fine, but we have to figure it out in terms of t. And then we just plug it in and go. So finding the limits means finding the coordinates of those points, but what we want is where the x-axis, where it hits the x-axis, so the x-axis is y equals 0. So what we really want to do is find t when y equals 0, which in this case is not, it's nice and easy, right? 0 equals t minus t squared, so this is t times 1 minus t, t equals 0 to t equals 1. And that actually makes sense. If I put those values in for x, the first one would be x equals 2, which is what the graph looks like, and the second one would be x equals 1 plus e, so that's like 1 plus 2.7, it's like 3.7, something like that. It looks like almost 4, that's what it looks like when you graph it. So that is what we want to do. So then what is our integral going to be? In this case, I'll see if I can write it. This is going to be hard to see, so I'm going to erase this and just write it here. Area is the integral t going from 0 to 1, and you don't need to put the t there, I'm just doing it to point out what we're doing. And then we want to put the g of t, which is your y, and then your f prime, which is going to be e to the t dt, and then we go ahead and do this integral. So, as is typical with the rest of the stuff in this chapter, you guys know how to do this integral. It's a little bit of a pain, right, because you have integration by parts twice, so I'll write this here, but it's really, or you can do it, well, however you want to do it, I don't care, but you just do it right. Okay, so the actual doing of the integral typically isn't the problem with these, but very much so it's the setting it up. And this one wasn't even too bad. So as long as you know this formula, you will be good to go ahead and get it done. So I'm going to end up with this. Oh, it's a minus. is going to be 2 integral t dt, which we already know. Do I get a plus? I get a plus. I get a plus. Okay. So just kind of, I'm going to try to make it fast because we already does that one. I know nobody wants to sit here and watch me do a million integration by parts. Eventually this, right? And if you evaluate that, your answer is 3 minus e, which is a small number, but this is a small area. That makes sense.